Imagine you have deployed 50 ESP32 boards in a warehouse. Few weeks later, you spot a data anomaly on your dashboard. The sensor values are incorrectly configured and you need to fix that bug in the firmware. To do that, we have two options. First one is to locate every single device, connect them to USB cable and reflash each one manually. And second option is to push a bug fix over Wi-Fi from your laptop while the devices keep running and watch them self-update one by one. In the production scenarios, the second option makes more sense. This option is called OTA, that is over the air firmware update. And today we are going to see exactly how to do that. We will deliberately flash a broken firmware initially to our ESP32 device and then catch the bug live on IoT cloud dashboard, and we will deploy the fix using OTA without ever touching the hardware again. Hello everyone, I am Hariharnath and welcome to IoT Frontier. So in short, if you want to understand what is OTA, we can consider there are three cars. And three cars are from the same manufacturer. For example, they found out there is some issue in the gearbox and they want to update that issue by sending a fix. So to fix this issue, there are two options. So first is like these cars can go to the service center and manually they can flash the latest update, or they can use over the air updates wherein they can get the updates from the manufacturer directly like we get for the Android or iOS updates on your mobile. So same way we can get on your car and that fix will be applied. Same way we are going to see with ESP32 board today. Coming to the hardware, we need ESP32 and DHT11 and some jumper wires. If you are using 3-pin module of DHT11, you don't need this resistor. Otherwise, you can use this kind of connections. So I'm connecting to this GPIO pin 4. So this DHT11 sensor reads both temperature and humidity on a single pin. So once the hardware connection is completed, we can go to the IoT cloud platform. So we have to set up the IoT cloud platform. So for this tutorial, we are using Anedya, which is a reliable IoT cloud platform, and it supports scalable and easiest way to do this OTA. So for that, you need to first get started. So you can click on get started and create an account. So I already have an account, so I'll click on this. So once you log in, you will be able to see the home page like this. So in the Anedya, you will be having different projects. So you can consider these as resource groups in your Azure or AWS. So we need to create a first project. So I'll create a first project, that is, so I'll create IoT Frontier OTA demo, and we can provide any identifier also. So I'll just put the same one, and you can provide the region. Right now it is supporting only India. Create the project. So now you can see project has been created. So once you are inside the project, you can see there are various things that you can create. So major important thing is node. So here nodes can be considered as a different thing or board. So ESP32, if you are creating one device, then that device can be considered as a node. So we have to create a node. So I'll provide ESP32 warehouse-1, and I can pre-authorize the device so that I can provide the physical device ID. So here the physical device ID could be anything which is like your MAC address or unique ID. So I'll simply give the same one. So we can add different tags. So these tags will be used in filters when we are trying to create the OTA deployment. So first is country. So I can say that the country is India, and I can say location. So location I can keep it as warehouse. So once this is done, we can create. So now you need to copy few things, that is connection key and physical device ID. So take a note of this in the notepad. So then click on finish. So I'll create a couple of other nodes as well for the demo purpose, but I'll be using only one. So for the second device, I can create a location as garage, and for the third device, I'll again use the location as warehouse. So now we can see there are three nodes created. 1 and 3 are in warehouse and 2 is in garage, and all of them are in the country of India. So that is the scenario right now. Next thing we need to create is variables. So variables are like different values that you want to read from the sensor. For example, DHT11 provides temperature and humidity. So those two we have to define in variable. So you can consider this Anedya as a Blink or UbiDots platform, and I'll just create temperature and identifier also the temperature and float as a variable type and create. Another variable is humidity and create this. while creating this project or variables, if you are facing any kind of issue, there is always a documentation available. In the home page, you can see know-how. So here docs.anedya.io, you will be able to see everything in detail. So project setup, everything is provided with a screenshot. So we can use this. So once we are done with variables, so this is the simple setup that we have to do in Anedya, our IoT cloud platform. So once this is done, so we'll go to the coding. So first we are using ESP32 inside this Arduino IDE. I'll just go to File, Preferences, and add this ESP32 index.json so that ESP32 is supported in IDE. So once that is done, you go to Board Manager from here and type ESP32, and you can see by expressive you need to install that. So once you have installed, the few things that you need to install in the libraries are Arduino JSON. So after that, Adafruit Unified Sensor, you need to install this, and the third one is DHT Sensor Library by Adafruit. So these are the three libraries we are going to use. Another important concept you need to understand in OTA is that the OTA process generally happens with two partitions. In the hardware like ESP32, you need to have two partitions. In the partition 1, you will be having the main program that is running. And in the partition 2, you can consider providing the new update that will be installed in the partition 2. And if there is any failure in the process, this will be rolled back to the partition 1 and partition 1 will be booted. To avoid any kind of issues, we need to have these two partitions. So by default, our ESP32 doesn't use these two partitions. So we have to make sure we use these two partitions. So for that, we need to go to our tools in the Arduino IDE, and in the partition scheme, you need to select minimum SPIFFS with OTA so that it will divide into two partitions. And here you need to select your proper board that you have, that is ESP32 board or whatever you are using, and the COM serial port. And this is the code. So here what we are trying to do is, we are trying to use DHT11, we are trying to read the temperature in Celsius, but when we are sending to the cloud, we are converting into Fahrenheit. So that is one issue. Another is DHT11 will have both temperature and humidity. So in this version 1 of our firmware, we are not reading anything from humidity. So we'll not see any kind of humidity values in the cloud. So here you can see the firmware version 1, and here you need to provide your Wi-Fi SSID and password. So another important thing that you need to update here is the configuration of the node. So we have copied connection key and physical device ID. Those are to be pasted here, and here you can see DHT pin configuration, which is 4, and other things like we are checking the OTA updates every 5 minutes, and we are sending the data every 30 seconds. So if you see in the send temperature, right now we are reading Celsius natively, but as we want to inject a bug here, so we are trying to convert Celsius to Fahrenheit. So then we are pushing that to Anedya. So for example, you are seeing 26 degrees Celsius, but you will see 78.8 in the board. Because in India we use Celsius, we have to make sure it is in the correct units. So in the next version of this code, we'll try to send via OTA the fix for it. And also, here we are just sending the temperature, and there is no call of DHT.readHumidity. So that is another feature that we are going to add in the next version. So I will be providing this code from the links in the description. You can find them. So once this is done, you need to upload the code. So for the first time, you need to use this USB cable to upload, and later part of this, we don't have to use the USB cable. So now you can see it has started, and it has connected to our Wi-Fi, and it is synchronizing with the Anedya time system, and after that it is polling for new deployment, because every 5 minutes it is searching for new OTA updates. So if you don't provide any OTA updates, it will simply be polling, and every 30 seconds it will be sending the data to the cloud. So you can now see right now I have 34.8 degrees Celsius in my home, and instead of Celsius it is sending in 94.6 Fahrenheit. And let's see how it looks in the Anedya cloud. So if you go to the nodes, you can go to the ESP warehouse 1, and here you can see view data. So under the variables you will be having temperature view data. So within 30 seconds you should be able to see new data that is coming. So now you can see 7:20:19 seconds we have one data, and let me check humidity if we are getting any. So no data for humidity because we are not calling it. So I'll wait for few more minutes to populate some data. So now I have placed this DHT11 sensor beside my laptop so that the temperature will be increased. So now we can see previously it was sending 94.64 and then it has rise to 95.36 like that. So this is how you can see the data, and we can understand that there are two bugs. This humidity is not working and these values are coming in Fahrenheit and we are not able to understand the exact Celsius value. So now we'll try to fix them. To fix them, we have version 2 of our code. So now I can simply remove the ESP32 from my laptop and place it on some wall or inaccessible area and connect my power bank. So now you can see my ESP32 is not connected to laptop, but still it is trying to send the data to the Anedya. So you can see the time difference. So previously it was 7:27:49 and there is a long gap because it has to restart. So it has sent another value, that is 7:28:55 seconds. So you can see the values are now coming every 30 seconds, which means even I am connecting with the power bank, I am able to see the data coming onto the Anedya. Now, as we have identified two issues, so to fix this, we have to send another firmware update, that is 2.0.0. So I'll just create another ESP32 program in Arduino IDE and make it as version 2.0.0 and update all these values again. So previously the method was send temperature data. Now it is holistic. It is saying send sensor data, wherein we are sending temperature and humidity and without doing anything in the Fahrenheit. Another important thing is, you can see my ESP32 is not connected right now. So I have to make sure this firmware is reaching to that. So for that, what I need to do is go to sketch, export compiled binary, which means there will be .bin file that will be generated, which I have to upload in Anedya so that it can deploy that firmware onto our ESP32. So now we can see it has done compiling. So this is the documents Arduino and this is the project name, and inside that build you will be having ino.bin. So this is the file that is important to us. Now let's go to the Anedya and go to the OTA deployments. So in the assets list, you can first upload an asset, or you can directly go to deployment and upload an asset. So I'll go to deployments directly and create a deployment. So deployment is nothing but to create or flash the OTA updates. So we have to provide it some strategy, like you want to schedule it right now, how many devices you have to do the updates, how to filter it, those kind of things can be provided in the deployment. So first I'll just name it as fix ESP32 units and I'll just start it immediately, or you can schedule it for later time. And then we need to upload the asset. So asset can be the binary file. So I have to provide like this, ESP32 Anedya v2, and we have 2.0.0 as a asset version, and remaining things can be blank. So now I'll need to upload. So I'll go back to that folder and upload this .bin file and upload this. So now we can see this is done, and we can also configure advanced options. So here you can set filters. So previously I have created 3 devices. So for example, if you want to filter with country, you can use India. So it will not change any target devices. But if you are using location, and here if you have put India, which is incorrect, it is showing 0. But if I use garage, it will use 1 device, that is device 2. And if you want to use warehouse, that is 2, means it is matching for device 1 and 3. And also you can create different stages, like you want to use single phase, that is 100% of all devices to be done in the same time, or if you want to give some delay, so you can use custom and give some delay in minutes, hours, and auto abort as well. So for now I'll just use single phase and create. Now I'll try to review the deployment, then create deployment, and it will be asking for deploying to 2 devices. Because I have only 1 device that is currently properly working, so it will ignore the second one. So first confirm it. Now we can see, so it is in the created state. So after few minutes we will be seeing this as active. We can get inside this as well and see what is the progress and success. Because our device is listening every 5 minutes for a new OTA update, so it will minimum take 5 minutes to reach the device and get this update. So we'll check back after 5 minutes. So after few minutes, if you see the update, it is saying active and successful 1. So if I get inside this, you can see success 1, and because other device is not working, you can see this is done. Now we'll go back to the node and check the first node, and here in the firmware assets you can see what is the update that it has, and we can also see the deployment history, which means that the deployment is started and also it is success. Now let's look into the view data and let's check if the data temperature values are correctly coming. So now you can see a sharp drop, because it's not because of the temperature drop, it is because of the units conversion. Previously we were using in Fahrenheit, now you are using in Celsius. Now it is correctly showing 35.8, and it's also coming after 30 seconds. So which means that version 2.0 is working. And another thing we can see is humidity. So in humidity also we can see two values, that is 16 has been shown here. So after few minutes you can see humidity is also showing some trends. So which means that the version 2.0 is successful. So this is the whole point we wanted to demonstrate. In real-time production scenarios, there will be thousands of devices, and all of them might be in different locations, and some of them are very inaccessible areas, like it would be mounted on your rooftop, etc. And then if you want to fix a simple bug or you wanted to increase the firmware features, then you don't have to worry about it. You just have to use this OTA feature and push the deployment remotely so that all the bug fixes and features can be delivered safely. If you found this video informative, please type helpful and smash that like button. If you want to get more such videos, please subscribe and hit the bell icon. Thank you for watching, and I'll see you in another interesting video.